Good afternoon, everybody, and here we are again from International Critical Communications Awards live. Myself, Robin Davis, and my fellow judges. Today I have the complete set, so I'm joined by Ian Ivory, Adrian Grace, Kevin Graham, and Sandy all the way from the US of A. So myself and my fellow judges over the next hour or so are going to hear pitches, presentations from the shortlisted candidates in the transportation category. I nearly said utilities then. That's tomorrow. Transportation category today. And we're going to have a presentation from Motorola on Galileo Airport, a presentation on Kirasun POC solution for a bus company, and then another bus company, Transport for London, talking about push-to-talk for school buses. And then we're going to finally hear about the deployment of LTE in Roissy and Orly airports from our good friend, Christian. Following that, we're going to have 20 minutes of Q&A. During that time, we're going to open up a poll. So anybody viewing, any of the public, any of the conference attendees out there, if you see a particular presentation, you think, oh, I like that, that sounds innovative, that sounds like it benefited the users, then please do go to the poll on your right-hand side of your screen and vote for your favorite presentation. What we will do as judges, we will only use the poll score should we get a tie in our scoring. So we go away, we score each of these presentations based on the material we've been presented, and of course the presentations itself. If we get a tie, we'll then go to the public vote. So ultimately the public, you viewers, will decide who wins. So enough from me. Let's hear from our first presenter. So we're going to go over to hear about Galileo Airport from Motorola Solutions. Over to you.
Okay, thank you very much. Good morning, everyone. Thank you very much for this opportunity. I'm very pleased to be here with all of you today. So my name is Alex Santos. I am a sales account manager at Motorola Brazil. And today I would like to share with you the Rio Galeão airport case. That is very important, the second largest airport here in Brazil. Okay, so first of all, I would like to begin my presentation with this statement from the Rio Galeão Airport IT manager, Ramon Allen. And basically is a quote where he talks about the challenge. So let me repeat here this quote. So despite the challenges, our team understood that the successful implementation of a new digital radio communication project would largely depend on the ability to integrate this technology with other airport systems and services. With a view to bringing more efficiency and security to the airport operations, and thus we launched the challenge in the market. So it's clear that this project not only focuses voice communication, but also data, and most important, the integrations between all those other applications that the airport was using already. So my presentation will highlight the main features and some integrations that was specifically developed for this airport's operation. Okay, so I would like just to share some numbers with you so you can just have an idea about the size of the Galeão airport here in the city of Rio de Janeiro. So basically 37 million passengers per year. Of course, that it was before the pandemic, as we know. 26 domestic flight destinations, another 25 international destinations. 1,800 Tetra subscribers is used currently for this airport. We have around 200 communication groups and around 3.2 million PTT per month on this system as well. So to cover all their airports, we have 2 sites. Each site has 8 channels. And one thing that I really like to share is that we have around 14 megabytes of short data messages exchanged per month on this system as well. So you can see that we heavily depend on the short data messages on the system as well. It's not only for voice, like I said. And we have all the integrated communications among 81 companies inside the airport. So it means that the radio communication is not only for the airport operation itself, but also for all the companies that operate inside the airport. So it means inclusive the coffee shop, for example, they have a Tetra radio device that they can just talk with the operation if something is in need. And just to introduce, like I said previously, the need it was for a mission critical voice and data system for the second largest airport in Brazil to ensure timely arrival and departure for travelers and cargo to the coordination of people and also aircrafts. That's something that I'm going to present as well. The partner, this is a contract, this is a managed services contract with Cofre. Cofre is the biggest Tetra operator in Brazil. They are a system integrator for Motorola for more than 25 years. And all the data-driven solutions and integrations was developed and implemented by another company called Anytopos. And the solution is a Tetra system from Motorola. We are providing the full coverage for around, like I said, 1,800 subscribers and a reliable voice and data communications from the moments that matter. So Motorola here is only the supplier of the communication, but Cofre and Anytopos, they are the ones that implemented, installed, and developed all the integrations that I'm going to present to you right now. So one thing that is important here on this slide, of course, that I won't go through all the details of this diagram, but I would rather, to state that our project, like I said, focuses heavily on the integrations that the flexible Tetra solution from Motorola using our APIs we can provide. So basically, we have here integrations with the PBX system, with the airport flight control, with the user database, with the Wi-Fi network, with the VHF aeronautic radio system. We have recording, alerts control, networks operation center from our partner Cofre. Now we have a Bluetooth scanner system, and we have many others. So here's just a way for you to see how integrated with other solutions this Tetra system is. Like I said in the beginning, it's not only for voice, but we are focusing on all the integrations that we can provide to enforce that the operation will run seamlessly, not only with voice, but also with all the data communications that we can provide. And right now, I would like to share some use cases about those specific features. And the first one is really simple to develop, but it was very important to the airports. That is the indoor and asset location. So basically, Cofre and Anytopos provided an indoor location solution, not only for all the Tetra devices using Bluetooth, but also for other assets. We can see an instance here in this picture, wheelchair, cleaning machines, segways. So the dispatcher is able to just take a look at the dispatcher screen, and he will be able to check the image of the airport, and he will be able to know exactly where the assets are, and also the Tetra users are using the built-in Bluetooth for the Tetra devices and Bluetooth tags for other assets as well. So this one is the first case, is the first feature that we developed especially for the Galeão airport, using the integration with the Tetra system from Motorola. The second one is the flight management system. Basically here, this is a system that we can share with the users information such as the airline number, the gate number, flight number, luggage carousel, and everything just to accelerate the flight landing and, of course, increasing the use of data. With this solution, Cofre and Anytopos was able to free up voice channels through this API integration, because right now you just have unified communications that will avoid the need to repeat the same information, minimizing misunderstanding. So in the past, the user was just pressing the PTT and asking for the operators where is the gate that that flight is going to land, and or take a look on the board as well, of course. But right now, what we did using the APIs, we just integrated those systems into the radio system. So right now, as you can see here on the left, on the radio, we can just see the text message with all this information. So the user don't need to just press the PTT and ask for information again, because they will receive in form of a text message all those informations about the flights that just arrived landed in the airports. Another one is the alert management system. This one is very interesting because this one is a wireless PTT panic button that we installed in each of the scanners. And the good thing here is that not only we integrated this wireless panic button using a Tetra portable radio with the alert management system for the airport, but we also integrated with our Avigilon cameras. So let's say that one of these users of these scanners, they press the panic button, automatically this radio will share this information, these alerts with the alert management system. And in addition to that, the nearest Avigilon camera will just change the focus to exactly that scanner. So all the airport security staff will have this information about not only what is the scanner particular that presses the panic button, but also they will be able to see through the Avigilon cameras which one presses the button and what is happening in real time. So it was another important feature developed to them as well. We have another one that's the flight service level agreement control. And this one is my favorite. And basically here we can control all the team's actions in real time after the landing to optimize operational performance. So the runaway team, they can record each step of simple commands on their Tetra handheld devices using pre-configured buttons. So using these combined features of Tetra status messages and electronic fences, it's possible to record all aircraft events on the runway. So for instance, I have a print screen here for a report that I can share with you. So basically here we can check the exactly time that each aircraft had its block on, had the choke ons as well, and we can see the exactly time that the bridge was connected to the gate to the aircraft. So using all this data, the airport's operation will be able to just check how many time it was needed in order to process all those steps. And since they have a specific time to perform each of these actions, here the report will automatically say that if it was within the time that the airport operation has to provide all those services, or in the case that you can see here, the first line, the third and the fourth line, that is a red sign here, it means that the time it was above the specific time for the service level agreement. So this is an important information that before that they were doing this using paper and pen, and right now with the radio we just automatically all the process. And in this image you can see here that we have a lot of electronic fences throughout the airports and the runway. And basically, we're using the location of the radios using the Bluetooth, because we can have a much more accurate location using Bluetooth in this case than using GPS. So we can just correlate the time and gate to know exactly which aircraft is at each gate. So this is how we can correlate all this information and provide all those reports for the airport's operation. And the last one that I would like to share is this flight control. This is important because, like I said in the beginning, it's important to know that all the operations between all the companies are integrating to this unique Tetra system that operates for the entire airport. So basically, we have an integrated communication among all the fuel and airline companies. So let's say that an airline company wants to use this fueling service. They will be able to just press the PTT and call those companies, and they will be able to just after that, an individual group communication will be created automatically, so we'll be able to talk to each other in order to provide these fueling services for through the airline operations. And of course, using ATEX radios because we have specific local regulations. So in this case, ATEX radios are in use to provide this solution as well. So with this one, I just end my presentation. I thank you very much for your attention, and I will be here to respond any questions that you have at the end. Thank you.
Good when I forget to turn off mute. Thank you very much. A very interesting presentation. We're now going to move on to hear from our colleagues from Kirasun, who are going to talk about push-to-talk over cellular solution and how that has boosted the bus company's operations. So over to our colleagues from Kirasun.
Hello. Hello? Hello, everybody? Is there anyone can hear me?
Yes. Just do your presentation.
Okay, I will start my presentation. So the first is my great honor for me to take this opportunity to show our company and also our solutions. In fact, how to see, our solution is a little different with most of the solution we present here. We use the 4G LTE solutions to support our customers, the transit bus company. So to start my presentation, first I would like to introduce myself. I'm David Dai from Kirasun International Department and responsible for the Asia Pacific market. And today we would like to bring our POC solution, POC radio solutions, boost the bus company / my operation. So now I will start my presentation. So generally for this presentation, I would like to take into several parts. The first part, I would like to introduce the parties which get involved in this how to say, case. And the first, we would like to give some brief introduction about our company itself, Kirasun. So Kirasun, in fact, I think some people know it and some people may not be very familiar with it. Kirasun, in fact, is based in China and is a worldwide leading professional wireless communication solutions supplier. That means we do not only do the terminals like the radios, handheld, mobiles, and repeaters, we also provide the solutions, including the DMR solutions, POC radio solutions, and security camera solutions. And we are specialized in integrated communication solutions for carriers and private networks. Generally, Kirasun has not only the office in China, we also have some branch office and base office in, for example, we have the Kirasun UK Limited in Cambridge. We have the Kirasun CIS office in Russia. We have the Kirasun headquarters in Shenzhen, and the Kirasun Philippine office, and also Kirasun Americans. So this is some introduction about ourselves as manufacturers and suppliers. The second, we would like to give some introduction about our end users. The transit coach lines with one of the largest family-owned and operated coach companies in New Zealand, deliver high quality transport and tourism service all over the country. So this is our end users for our case today. The third one and is our partner Singular NZ Limited offers reliable communication solutions to New Zealand business through constellation, planning, design, and installation, and ongoing maintenance on communication systems that deliver exactly what business need. And in fact, we started cooperation with the Singulars from the year 2017, and at that time, the first business cooperation is on the POC radio solutions. So this is what is the general introduction about the three parties who get involved in today's case. So the first, we would like to give some background for this case. In fact, we would like to show to go some explain about what really transit company is the background and what they really is the business developing and also what is the real need. In fact, transit is, as I said, is a family coach companies, and they used to rely on an analog radio system for communication between buses and the dispatching center. The system contributed to the company operation and growth. However, this analog system is very limited, become obviously when transit future expands its nationwide business and pursue high safety for its customers. The analog system has limited geographic coverage, and the mobile units did not support GPS locations for buses and on the move, and the dispatching system support only control room to bus one-way course. That means the dispatching system can only call the bus, but the bus cannot call back. Therefore, timely response would be held in case of any emergency on the road. That means if there is any emergency happen on the road, and maybe the dispatcher center may not know about that. And the transit was looking into different options on the market. Push to talk over cellular is POC radio technology. Selling points are attractive. It taps into current nationwide networks, solve the coverage issues, and at the same time, lowering the system ownership cost dramatically for customers, while offering all the features. Traditional PTT service has POC terminals are much stronger in data and multimedia. Working with its local partner Singulars, Corazon has supplied a full solutions with network management systems, dispatcher systems, and now over for 2,000 set of M50 mobile POC radios since 2018, a local server, and also was set up in New Zealand, along with 2 backup servers. In fact, we totally have 3 servers in New Zealand. One is the main server, and the other is two backups. In fact, during the last 2 years, even some small issues happens like the earthquake, our system is still running very stable. The whole system is highly reliable and resilient, and transit is very satisfied about our performance. So this is the background and what they are really need. And in fact, the story is generally happened from the year of 2017 at that time. And here I would like to show you some pictures about our dispatching system. So you can see from the picture, our dispatching system is web-based on the web-based. That means you no need to install the dispatching. You can go anywhere with your computer, with your mobile phone, or even with your laptop, with your iPad or some other smart media. So you just enter the website and give you the account and password, you get into the dispatching system. And you can see here, you can do the individual call, group call, and you can even organize any groups as you need. And you on the dispatcher center, you can also see the maps and see where the buses and where are they. And if you want to call anyone, you just click them, very easy. So this is how to say, very user-friendly dispatcher center. And the next one is our terminals. This one is the M50 POC mobile radio, and it starts is going on the market from the year of 2017, and now we have the 2 versions. One is the 3G version and one is the 4G version. This is very popular right now in American market, in New Zealand, Australia, and even in some Asia markets like Korea, like Vietnam, and some other countries. So this mobile radio, POC radio, I think is one of the earliest mobile POC radio in the market, and is also totally designed and manufactured by Corazon. And we can see that, in fact, from 2017, when transit, they purchased the buses from China, we deliver those radios to the bus manufacturers, and the bus manufacturers and install our radios in China into the buses and deliver to New Zealand. And the end user no need to do any installation, any configuration, all the systems and all the parameter settings is from Corazon and pushed to them. So it's one-stop solution. So you can see this is the mobile radio which is installed in the bus. And now I would like to introduce some of the features, the project benefits of our POC radio systems. And the first is fully comply to the local traffic laws and regulations. M50 mobile terminals are installed on the buses for easy access and operations. We can see, in fact, in the transportation area, there is very limited for the handheld, because for most of the countries, the regulations and the laws are not allowed the drivers to use the handheld. So we developed this particularly mobile POC radio. The second is, since there is carrier coverage, that means 4G or 3G coverage across the nationwide network, this POC radio system is nationwide. It's not compared, we mostly compared to the DMR system. For DMR system, they need, if for short coverage, they need to use the repeaters or use something like what we call IP link or solutions. For large coverage, they used a lot of infrastructures, including the base stations, antennas, or even the microwave links, something like that. But for this kind of POC radio solutions, we no need anything from outside. We use the existing coverage, the 4G network coverage. That's enough. So in this way, the end users' investment for these solutions is very, very low. They just need to pay for the terminals. They need to just pay for some license for the end user for the terminals. That's enough. The third one is the multifunction dispatcher provide quality service such as voice calls between buses and control center, call recalls, GPS locations, SMS, and geofencing. We do understand for traditional DMR radios, if, for example, if we use the IP link solutions or use the trunking solutions, we still can get those kind of service. But in fact, from our users' experience, those functions is not very easy to realize. And in fact, those functions, and you need to pay a lot of money, you need to do a great investment on them. For example, for the GPS, mostly we can see that the DMR GPS, they are not very accurate. But for POC radios, they have two systems for the GPS. One is from the GPS chipset, from the radio itself. They communicate with the satellite, the GPS satellite, so they can get the position. The other way, they can use the AGPS, which they can get the location from the towers, 4G towers, antennas, and something like that. So in this way, the POC radio GPS is much, much more accurate than the DMR solutions. So, and the operations is also much more easier, like the geofencing. And with a single push on the alarm button, the emergency is reported to the control center immediately, and proper actions would be taken tightly. We can see, if we still can remember, we can see from the mobile radio, there is a very small red button. That is our emergency button. If there is any emergency happen, the driver just use one push on the button. Then the dispatcher center can get a alarm and know which bus is there is an emergency and what is happening and where is the bus is right now, so they can take the proper actions. And in fact, for that, I would like to see something more. In fact, for Corazon, we also do some customization for this company, for transit company. We put a separate button connected to the mobile radio so that we're hiding the emergency button under the operation desk of the car so that nobody knows there is such kind of button. When there is emergency happen, the driver can secretly push that button. So from the other people, it seems nothing has going to happen, but in fact, the alarm or the emergency alarm is already come to the dispatching center. So I think in this way, in some particular emergency happen, that would help. the last one is the user-friendly NMS, make it easy to form or modify groups and adding new users and managing our system. Okay, so this is generally a brief introduction about our solutions for that transit company. Thank you for everybody's, and if there is anything, questions.
Thank you very much, David. That was
thank you.
That was great. We will please stay on. We will collate our questions. We will ask you the questions once we have heard all of the presentations. So thank you very much for that. Moving on swiftly, we would like to welcome Thomas Brewster from Transport for London. So we're going to move from one set of buses to another set of buses. So let's hear all about push to talk for supplementary school buses. Thomas, over to you.
Absolutely. Thank you ever so much, Robin. And first of all, I'd just like to say very many thanks to the judging panel for shortlisting our project for this award for what is TfL's delivery on push to talk for supplementary school buses. And this is a project that I delivered on behalf of TfL to London Buses. So what I might just do just to start with is just outline that for those not familiar with us, that TfL is responsible for running transport services throughout London, capital of England. And one service that falls under our remit is London Buses, and it has a fleet of around 9,100 vehicles that run on approximately 670 routes, and of which within this as a subset, we have 72 school routes. And this project focuses on providing additional capacity on these school routes. And when the judges and the public take a look at this presentation, I want them to think about this in two ways. First up, I'd like people to think of it as a way we really effectively and proactively responded to a big business challenge to very, very tight timescales. And I'd also like people to see this as actually, we didn't just deliver this thing, we actually have enabled this platform that the business can reuse going forward in other capacities. So ultimately, what were the project drivers for this? TfL were required by the Department for Transport to provide at very short notice extra capacity on our school bus routes. And this was to enable a socially distanced return to school for London school children. We had a series of must-haves, which are bulleted below. And as you can see, incredibly tight timescales. We had to deliver a comms solution within 4 weeks, ready for the return to school of London school kids. We had to provide an emergency comms link into TfL's network management control center and the ability for the subcontractor to also communicate with a garage that they are contracted to. It needed to receive safety messaging from our NMCC. The buses needed to also be tracked to monitor contractual performance. And the real challenge with this one, what made this project so different, was it was foreseen that it was going to be up to 80 buses that were going to require this technology. But ultimately, the precise number, the exact bus types, the London bus operator they were going to be contracted to, and the install locations were only going to be finalised 1 week prior to deployment and physically accessed up to 24 hours before go live. So as a result, this was quite an exceptional project to move to some really, really tight timescales. And as you can see, the vehicle availability being so close to go live, we couldn't just roll out a spare set of radios from our existing radio system. And it forced us to really think outside the box and come up with a really new solution to this problem that we had to be in for day one. Because on a TfL contracted school route, no radio means no service. So as you can see at the bottom of this slide, we progressed from our project kickoff on the 7th of August this year to a service go live with a developed solution on the 4th of September. So what actually made us select push to talk? Well, it's obviously it's technology as an agile form lends to very, very rapid development. And we implemented last January a new push to talk over cellular solution. So it is a new service to TfL, but yet we were already thinking, how can we leverage our position here and modify our existing solution for an in-cab environment? So previously just used on street, but now we had to make this ultimately compliant within the cab environment, which brings a whole new set of challenges. We had to be exceptionally creative when it came to actually developing the solution, because every function of operating the smart device, or the push-to-talk over cellular device, had to be operated by a remote Bluetooth speaker microphone by one of 3 button clicks. So the ability to talk to either the emergency responders or the garage all had to be done using a very, very minimal footprint. It was incredibly innovative, this solution as well, because granted, push-to-talk over cellular is now quite a common service, but ultimately ours isn't, because it's actually fully integrated with our existing DMR network. So that means that we can take advantage of talk groups that have been system-wide configured, and we can make a push-to-talk user who has just joined our service effectively part of one of our bus operating companies, just like that. The service has been incredibly reliable from day one, and the push-to-talk system now has over 350 active daily users, and we've actually only had 1 ticket raised to our help desk since go live in early September. And ultimately, what makes this a real success for us? Well, ultimately, it was really fit for purpose for our users. This solution delivered all of its must-have requirements and was delivered ultimately to time, cost, and quality. So ultimately, what is it? Well, it's an integrated comms solution that's accessed by a rugged smart device. And I actually have one right here in my hands that I'm going to put up on camera for you. So we have the smart device right here. It's not actually turned on because it would be broadcasting to us as we speak. And it sits within a mounted cradle within the cab, and it's not coming out. And it's actually stuck with what is a high pressure suction cup on the back, which enables us to actually mount in any fixed location within the cab. So we can install this within a compliant location. And it's ultimately controlled, making it a 2-way radio device as opposed to a smart device operated by this remote speaker microphone that I mentioned. And simply put, you press one of the 2 side buttons to communicate with your garage controllers, or in the event of an emergency, you press and hold the red button, and that will initiate a call over the smart device into our network management control center. So we now actually have this off-the-shelf solution that can be provided to any service vehicle or contractor that is going to work with TfL in order to provide communications with our main control center and their dispatch location. And this doesn't actually even have to be on this device per se. We can just release the app to a device or a smart device of our contractor's choice as well in other contexts. But ultimately, this is a ruggedized, fit-for-purpose solution that we developed for the in-bus cab environment effectively. So not only can we provide this communication, we can also track the live location of devices for the purpose of safety management. And we can also show, as you can see in the bottom right-hand corner there, breadcrumb tracking to ensure the contractual compliance. So ultimately about this delivery, what was so complex? I mean, we've spoken about the timescales itself, but what needs to be considered here was it wasn't just a case of rolling out a piece of kit that we had on the shelf. Within 4 weeks, we actually had to go from scratch essentially with this to design, develop, test, and deploy the solution just in 28 days. And I've listed below there just some of the challenges that we met at each of these phases. So in terms of options, the solution actually required approval with our bus operating companies, TfL bus operations, and our unions before we could even commit to actually placing an order. In terms of the design as well, we had to be vehicle agnostic. We had to also ensure compliance with the UK Road Traffic Act as well, ensuring that it meets the standard for a 2-way communications device. It had to also then obviously be rugged to be used within a garage operating environment. When it came to testing, we shrunk our lead time to deliver by conducting our testing on a baseline device whilst the order was placed and we were waiting to receive the product. In terms of delivery, well, shipping lead times really pushed out during the COVID era. And this is primarily due to a reduced volume of available cargo space. And contrary to popular belief, most cargo doesn't actually come in cargo aircraft per se. It comes in the belly of regular jetliners. And as we're all aware, there has been a drastic reduction in the number of flights. And you're also competing for that cargo space with PPE as well. So we had to also deliver this obviously in a socially distanced way, all the way from develop through to deployment. And then when it came to then rolling out this thing, we'd managed to build it, but ultimately getting 100 users operationally ready within 24 hours of go live was no mean feat. And we could obviously only train these guys when they had the devices in hand. But these are ultimately the complexities that we faced on a project. And I think anybody who actually works in IT on projects, we're quite used to playing the role of a football referee, whereby if a project has gone particularly well or introduced seamlessly, we basically are invisible and we had a good game. But this was a particularly warming one because our customers really recognized what we had delivered here. And I've just got a couple of comments on what they had to say. Now, first of all, we're going to hear from one of our external companies, Stagecoach London, who supplied a number of vehicles on our school bus routes. So if I could just introduce the video from Tony Peters, please.
Hi, Tony here from Stagecoach London. We were asked to mobilise 25 additional buses to support the new school term in September and could only achieve this using buses from our sister companies around the UK. These buses were not fitted with the iBus radio system, so we had to think of a way to communicate with them. London Buses and Take came up trumps with their push-to-talk app, something we have used to its full potential since its inception. This gives us and NMCC the ability to talk to our drivers and track them on a map. The kit is very robust with no failures seen so far, and the rollout was seamless. Training was delivered by Tom over video link, but the beauty of this product is the ease of use. We are able to show drivers what to do in only a few short minutes, meaning we can change drivers at short notice. The controllers are all very impressed with the quality of the calls, so all in all it's a big thumbs up to everyone involved in delivering this solution at such short notice.
So that's one of our external customer opinions of the product. We also have a number of internal customers within TfL. The primary key stakeholder being our network management control center, and Neil Wood manages this team of dispatchers that take emergency calls through this service. So I'll just introduce his video now, please.
It was really good with the tracking and the breadcrumbing, breadcrumb trails and that within the tablet that we're using in the control room, and also the hands-free application that allows the guys to actually not have to be that close to the tablet to actually talk to it. So again, thanks Tom, thanks to the team. The push to talk, I can't recommend the application enough, and it's also enabled us to be keeping contact with people that are working from home and for them to monitor the app. So again, well done, thank you very much.
So all in all, our customers have been very impressed with not just the product, but the way it was delivered in such a challenging circumstance, and ultimately its reliability since go live. Just for my final slide, what I'd just like to say actually on behalf of myself coordinating the project is, regardless of whether ultimately this submission wins this award or not, I'd just like to take a moment just to say a really big thank you to what has been an extraordinary effort from a number of people in order to meet this really quite tight delivery deadline. And thank you very much to CCW for the opportunity to present. Thank you.
Thomas, thank you very much for that. Very enjoyable. I would like to just take this opportunity to thank all the presenters and all of the submissions so far. So thanks for that. So now moving on to our final presentation. Our final presentation, again, from somebody we know quite well in the TCCA, Christian Arena, who is going to talk to us about LTE at Roissy and Orly airports. Over to you, Christian.
Yes, thank you, Robin. Do you hear me? Yes, okay. Thanks, everybody. It's a real pleasure to be there today and to show what we are doing in Roissy and Orly Airport for critical communication. I'm an enterprise technical architect for Air France KLM in business critical connectivity, but I'm also a co-founder and member of Agur Association in France. It was created in 2012 to obtain spectrum, private LTE spectrum for verticals in France. The first step for us is to explain what we have regarding the critical communication in an airport, focused on the operation around an aircraft, because it's our activity for an airline, it's aircraft operation. And you can see the number of networks that we have today onboard networks like VHF aircraft and public networks for the crew, and also a Tetra network, sure, the PMR for operational staff, and also the Wi-Fi for the private SSID. The first step in 2021 is to deploy and to remove the Wi-Fi networks that you can see on the left, and to replace by the private LTE network with a dedicated spectrum, to be in the same SLA on characteristic of the PMR of the PMR of Tetra. It's the first step for us, and it's really the main step on the first step for all of the other deployments that we will have to do in the other steps. I will explain that after. A second step, it will be I hope in 2022. Sorry for the COVID. It was we are a bit late, but we want to deploy a Tetra gateway between the LTE and the Tetra private network to be able to replace step by step the different operation and staff to switch the Tetra operation to the LTE operation, but through a PMR. Also, the PMR, it's a push-to-talk solution. We want really to do that, but step by step. It's a first step for us to do that. You can see the number of the devices that we have, the tablets, on the tablets for the onboard, the tablet for the crew, the tablet for the staff, operational staff. For your information, today we have 20,000 tablets on 40,000 headset of PMR on the both airports. It was not the case for 5 years ago. For 5 years ago, we had many headset of PMR and nothing in tablets. Today, really, it's a change that we see for the verticals on the operation, like the airlines, is the fact that the convergence of both networks are coming, and are coming really are coming soon. It's a third challenge for us. I am an architect, and I have to show a global but high-level architecture. I don't want to show a big picture because it's a bit complex and it's not easy in one slide, on only one side. But the particularity of this network you can see on this slide. The first step is to have a common RAN sharing. What can I say, with Hub 1 on Aéroport de Paris, because Air France is one airline, but we have an airport on the same location on a lot of other airlines in the airport. It's the reason that we wanted to share the RAN, to have a RAN sharing on the airport to share the frequency. Today we have 20 megahertz for our own usage, on 20 megahertz for the rest of the airport in Roissy and Orly. It's a dual core Air France KLM on Hub 1. But it's a first step to deploy that, and it's a big job for us in 2020, 2021. We will deploy also for sure the rest of the infrastructure and the architecture, but also the OTA is really new for us and for the verticals, to have the logistic regarding the SIM card and to be able to change something on the SIM card. It's new for us, but we have also MDM. It's not new for us. Data center, interconnect, data center, intranet, extranet, etc. It's for the data, as I mentioned before. It's really the first step. It's the data. The other step in 2022 is the new services, mainly linked with the devices and also like voice, push to talk, etc. It's really what we want to deploy after in the Tetra gateway, for example, on the push to talk solution, but also the interconnection with the telephony on some other media application. Again, it's the fact that we have a convergent solution and we need to have a converged application. It's really what we want to do today. Tomorrow, sorry for that. Yes, mainly the network characteristic, because I think that it's really particular for the airport. It's the PMR coverage deployment model. It's really what we want to do. It's reuse the spectrum and concentrate coverage where the business requires it. You have 90 metro cellulars in front of the plane on each Air France KLM parking lot. Long haul, medium haul, it's really after the POC, the proof of concept that we made in 2017. we discovered that really the main coverage that we can have, it's one antenna with 5 watts in front of each aircraft to have the best connectivity around the aircraft and inside the aircraft with 2.6 gigahertz. It's important to mention that the spectrum in France is 2.6 gigahertz TDD. And again, the difficulties, I will show that in the slide after, it's interlacing that we want to do with of the RRU and BBU to preserve a minimum of car park coverage in case of malfunction of one of the components. It's the same as the Tetra network today. The Tetra network, we have 24 base stations in Roissy Airport, and we multiply the number of base stations. Is really to be sure that we have a back coverage at the end. We have no, how can I say, no stop of this kind of network. It's really what we want to do with this kind of new networks, the private LTE. And also another step for us on another challenge regarding the private spectrum. It's the spectrum is rare, and really we want to optimize the spectrum. It's the reason also that we want to do with the aircraft parking on all operation around them. It's the fact that we are able to reuse our 20 megahertz for each aircraft. And at the end, we are able for each aircraft, long haul, medium haul, no problem to have 20 megahertz. At the end, we have 40 megabit for each aircraft, and we have the best, again, the best usage. You can see at the end, for all of the parking lot in Roissy and Orly, we are able to use 1.8 gigahertz. It's really interesting, I think, for us. We have also, for your information, 24 microcellule in MOCN mode. It's really, again, a RAN sharing with Aéroport de Paris to be able, for sure, not only the parking of the aircraft, but also to have the mobility around all of the surface of the airport. It's really what we want to do. In progress. It's what we want to do, and it's another challenge for us. It's a hybrid solution. Sure, the private LTE network, it's for Paris Airport because we are the main airlines in the both airports. We have, before the COVID, we had 1,000 flights per day on the ground. And it's not the case at the end of the line. For example, in London, for example, in New York, we have 2 or 3 aircraft, we have 2 or 3 flights per day. And the challenge is not to have a private network on this kind of airport. But if we are able to interconnect directly our private core with one or other MVNOs to be able to have the same kind of connectivity for the rest of the airport, I think really it will be interesting. At the end, we will be able to add 12,000 connected crew tablets. Today it's not the case because the crew have a tablet for the flights, and they have a SIM card. If we are able to give a SIM card for the private LTE in Roissy, they are not able to use in New York or in London. We want really to have a common SIM card with a private network of Air France KLM, but also with the MVNO to be able to use it at the end of the other line. It's really what we want to do, and we have a lot of discussion with some MVNOs today to be able to have this kind of opportunity. Another step with that is, for example, the OTA on the logistic. If we are able to check with the MVNO to take the logistic of the SIM card of our private network, it's also another step. And for us, it could be a good challenge for the verticals to have the opportunity to use it as a service and not to be the owner of this kind of platform. It's really what we think that we could do after. Yes, I mentioned before the principle of Metro Cellular on each parking. You can see the one part of the airport in Roissy is the part where we have all of the aircraft of Air France and KLM. You can see the number of the parkings. At the end, again, the fact that we are able to make an interlacing of RRU and BBU to preserve a minimum of aircraft park coverage. It's really a big difficulty with the airport, Paris airport, to be able to have that, and it's really a lot of discussion with them to understand why we need this kind of interconnection. It's really to preserve again the operation around the aircraft. The optimization of the spectrum again is really centered on Air France-KLM's core business, aircraft parking, on all operation around them. Again, the operation around the aircraft, we have 120 tasks per flight. And at the end, we have a lot of operation, and we cannot lose any minute, any second in a trouble with the communication. For your information, but it's the same. It's an early airport, but you can see it's not really. It's more easy. It's easier for early airport, but it's the same challenge to deploy one antenna per aircraft on this kind of airports. The first picture that I showed before, it was the different networks. And at the end, the target, it's really to have one common private LTE network to be able to have the convergence of all of the media on this kind of connectivity. You can have directly the onboard crew connected if you have how can I say, a contract with some MVNO. We will have directly the connectivity, but at the end, if you're able to add some other critical communication like the IoT, like LTE-M, I think really that we will be able to hear again time on time on the parking. At the end, with one platform, the IT, the telecom part, we have one unique platform. It's a private LTE. And if you are able, thanks to the 3GPP, to have the different release and to be able to upgrade this kind of platform, I think really that we have the opportunity to add and to be more, to have the best performance regarding the collaborative tools on the communication around the different operations. The control and command on the left, you can see the control and command. And today, if you have some trouble on the parking, it's really difficult. The control and command agent has to call through the PMR to check with the staff on the ground where is the car of the kerosene, the fuel, for example, where is it? Tomorrow, if you are able to connect directly with the same application, all of the items, all of the things on the ground, we are the winner, I think, regarding this kind of challenge. Another way regarding that, for sure, it's also the autonomous vehicles. At the end, it's the same. We have some proof of concept today with some manufacturers through Wi-Fi. And for me, sorry for the Wi-Fi provider, but for me, it's a pity to make some autonomous car in the airport, on the airport through Wi-Fi. In place of the private LTE, if we are able to do that, to put on the private LTE, we have the best coverage on the airport. If we are able to make this kind of proof of concept through this kind of infrastructure, again, we will be the winner for the future. It's really what we want to do. And for me, I think really that it's a big challenge for the next year with the arrival of the private spectrum, to have the convergence, but not only for the human, for the people with the voice, data, video. I forgot to speak about video. We need a lot of video on the ground today, but also with all of those things, the cars, and at the end it will be the smart, not airport, but the smart airline. I hope it will be the smart airport. It's another aspect regarding that, and thanks again regarding the 3GPP and the different release. If we are able to deploy 5G antennas around the taxiway with the 5G NR. Sure, it won't be the 5G SA because we have the core today. On the core the private LTE core, it's compliant with the 4G on the 5G NR. And if you are able to deploy some 5G NR antennas around the taxiway and keep the 4G antennas on the parking aircraft parks, I think really, again, it will be really the best for us. And we have a lot of discussion with Airbus, for example. We are European and we discuss with Airbus, sorry, Boeing. And we have a lot of discussion, and we know that the Airbus A350 will come in 2022, I hope, because of COVID. In 2022, we will have some Airbus compliant with the 5G on the 2.6 GHz TDD on 3.5 GHz for the other countries in European area. And at the end, if we are able to connect directly on the taxiway through the 5G, the aircraft, to have the predictive maintenance, to have some local IoT on the taxiway, we will earn again time on time. It's really what we want to do. And at the end, we will have again the best of the best, I think, regarding the connectivity. And you know that we have also, as I mentioned, in the same time, the public network. Sure, we have the public network. It's not always the case on the taxiways. But at the end, it's not possible for an airline to take the traffic in place of the passengers. And it's really the reason that we think that we could have, and we need to have, a private spectrum, private network, private infrastructure to do that. It's finished for me. It is some use cases, but some challenges that we have. Thank you very much. Finish.
Thank you very much, Christian, for that presentation. Again, very interesting. Ladies and gentlemen, we have heard from Motorola, Kirasun, TfL, and Air France, KLM, and Christian. I thank you all, as I said before, for your submissions and your entries. I know it is not easy. Polling should now be open. So the organisers should have opened up the polls. So please do submit your vote for your favourite based on what you have heard. That will be great. We have a little bit of time left. I do have a couple of questions. And my first question I would like just to ask David in Kirasun, whether your push to talk over cellular was actually 3GPP MCPTT compliant.
Okay, I would like to answer this question. Frankly speaking, right now our port radio system is not fully compliant with the 3GPP MCPTT, but we have been working for that since the first time we developed our system, and I'm sure for our solutions, we are always trying to use the standard, international standard one, and we will achieve that goals. Yeah.
Okay, brilliant. Thank you, David. And then I have one last question from me for Christian, which is, am I right to think that we as the ICCAs have seen the submission from Royce and Orly before? And if the answer to that is yes, we have, what is different from last time to this time?
The difference, it was the fact that it was a proof of concept and it was just for 4 parks in the airport on Roissy. And today it's not 4 parks, it's really for the global coverage, the global project to deploy this solution. Today it's a real, it's in reality, and it was just a proof of concept the last year.
Brilliant. Thank you. I just wanted to ask that because I did think I'd seen some of it before, and either that or I had thought about it in my sleep. So I just wanted to check I wasn't going mad. So thank you to that. Few minutes, other judges. I've had a message from Adrian and Kevin. They are both happy. Sandy, Ian.
So I'm relaying one question that came in on the chat, which I've done some explanation, but it's for Thomas. And the question relates to hands-free operation. There's interest from the audience about legislation around hands-free use. So I wonder if you want to expand on the legislation and how you address that.
Sure, absolutely. So absolutely right. It becomes it becomes a moot point if you pick up the wearable device, essentially. So as long as it's in a fixed location within the cab or is worn and has not got to be picked up to be operated, it makes it compliant. That's it in a nutshell.
So my understanding was you had maybe I misread it. You had a Bluetooth remote speaker microphone, and that would be what the drivers would use, because I know that the legislation is changing. I thought actually interacting with the screen itself was prohibited.
That is correct. Interaction. If I show you on this mock device, you're absolutely right. So this is fixed in a location that cannot be touched by the driver when they're in their sat driving position. So the beauty of this solution is it means it can either stick to paneling or it can stick to glass. So we can ensure that actually this is put away where the driver cannot play with it. And the driver has a choice. They can either have it in a fixed location within the cab on the dash, or they can simply basically tag it to their clothing, and as long as they don't pick this up and press it, that's compliant.
Right, and that device you're wearing, that's the remote speaker microphone with the PTT button?
That is correct, yeah.
Brilliant. Thank you.
Okay, Sandy, do you have anything for our excellent presenters?
You know, my question was also around the device in the buses, so I think I'm good. I think I'm all set. The presentations were very clear. Thank you.
Thank you.
Okay, yeah, brilliant. I mean, I would just like to say to everybody again, thank you very much for clear presentations. I know this isn't easy. I think, well, hopefully the audience will agree that it went a bit smoother today than it did yesterday. You didn't see my face popping up so many times. And I've got Adrian Scrace on this side of the organisation with his face in a purposely built window now, which they spent all night building. It's a bit like a Grand Prix, Adrian. They actually spent all night building that box for you to appear in on the screen. So much better day for us technically, and thank you to the organisers and the video team for making that work. Thank you to you all. We as judges are now going to go away and have a little chat about those things. And remember, the poll is open, so please vote. I expect some of you will get all your mates to vote for you. I did notice something yesterday where I think poll shot up literally within seconds. Must have got one company to vote for everybody. Whole of Europe, I think, in one point. But please do vote. That helps us if we have a tiebreaker. If we don't have a tiebreaker, there's a clear winner between the judges. We don't look at the public vote. If there is a tiebreaker, we will. So it is handy. And remember, tomorrow, same time, same place, we are going to do best use of critical communications in utilities. And then on Friday, we're going to announce the winners. So I thank you all. I wish you all good luck. I don't actually have a clue who has and who hasn't won. We judges will go away and have a chat shortly. So thank you all. Thank you for joining. I hope you enjoyed that. And we will see you all same time, same place tomorrow. Bye-bye.